Thanks for coming to the closing keynote. I'm super impressed. I have energy. I hope we all have some energy for like a deep dive into Istio. This is not going to be a grand ideas talk, but I hope we can survive till the beer. There have actually been a bunch of great talks on Istio so far at this conference, so I'm not going to go through that content again. This isn't Istio 1.1. Also, 30 minutes isn't very long, so I'll go into the details on this. Cross-cluster calls made easier, if I'm quite honest, with Istio 1.1. Certainly easier than they were before. So we'll have a look at that. I am Matt Turner. I'm from London in the UK. I'm with Native Wave. We're a consultancy that helps people move to the cloud and become cloud native and modernize their IT organizations. So I'm around in a Brig t-shirt if you want to talk about that. But now I'm going to talk about Istio. So I will cover a quick recap of how networking works within a cluster, like really quick, but I know we're all tired. We'll then look at ways that you might be able to make calls between clusters. We'll see how Istio can get involved with that and help as a service mesh. We'll then look at the new features in Istio 1.1, which makes that marginally easier than it was before. And I will then attempt to demonstrate it, but that does involve like managed GKE clusters in multiple regions around the world and conference Wi-Fi. So I've got it recorded though, so it can't go wrong because I've hedged it. So like really quickly, remember when we had computers and they looked like this? This is the Windows 95 My Computer logo. They genuinely did look like that. They were fine. You could play DOS games on them, right? You could play Civ 2 and everything was good. But if you wanted them to talk to each other, you had to add a switch. And then they were on a network. Now, our computers aren't computers. They're containers. The isolation is done by software, not an air gap. And they're inside another computer, which is great. But how do they talk to each other? Well, you add a switch. This is a virtual switch, just like the isolation mechanisms for these containers are software. This switch is implemented in software. But now we have two computers. We got scale. We got users. It's very Web 2.0. Scale's great because it pays for your avocado on toast. But the problem is this container has to be able to talk to this container, and it's only got a switch. And of course, realistically, your estate's probably larger than this, right? Google has more than these two computers. Kubernetes will support 10,000 or so. So how do we get them talking to each other? We had a switch. And this effectively, I mean, there's details, but this effectively is a Kubernetes overlay network, right? So we can zoom out a bit and we can say that this pink box here is what's called the overlay network. So any pod on any node can talk to any other pod on any other node through this overlay network. And that's great, because this is Kubernetes' job, right? It's to run these containers on multiple machines at the end of the day. And if it's going to do that, you need some basic functionality in place. So we can remove some of these layers of abstraction, right? The network, the overlay network kind of works. If you're still in that place of rolling your own Kubernetes, then why? But you know you had to install Flannel or Calico or whatever. But we can remove that. We can assume it just kind of works. And in fact, we can zoom out a bit more because we don't care where the computers are, right? Because this is Kubernetes. This is the cloud. So we have these containers running in this ambient compute, and we have an overlay network. It's a layer 3 network, right? An IP network. And they can all talk to each other. Then along came the service mesh. We love service meshes. So we can put a sidecar. We can put an HTTP proxy alongside our container. This is obviously Envoy. And then the gray box is the Kubernetes pod boundary. I guess technically the network namespace part of the implementation of a pod. But this is sort of network isolation. And then no container talks directly to another container. They all talk through this proxy, which adds a bunch of value. So this is a mesh of services with their proxies. So if we zoom out again, we find that the context this lives in is a Kubernetes cluster, right? Istio or something like that will run outside of Kubernetes, but the most common deployment strategy is within a cluster. So we have this kind of gray amorphous blob of compute ability, compute power. Some pods run in it. You know, they all share this overlay network, this pink overlay network, and there's a Kubernetes control plane up there. So we as users can interact with that and tell the control plane to do things in this cluster. And actually, if the pods are aware, the pods are able to call that API as well, and they can affect their own environment if they have permissions or whatever. So the service mesh we saw before, the subtle change is the addition of that little sailboat. The mesh of services we had before had proxies. they do stuff, that's great, but manually configuring them kind of takes us back to the 90s. So a full service mesh, something like Istio, comes along with a control plane, which much like the Kubernetes control plane gives us a nice API that we can talk to, and we can declaratively say, well, I would like my proxies to be set up like this, I would like them to be doing this for me, and the Istio box of tricks takes care of working out what the Envoy configuration files look like and propagating them out to do that. So that was Istio in 3 minutes. I hope that was OK for everybody. I hope we still got some energy. But now we zoom out again. Right now, we don't just have our 2 computers, me and my friend playing Command & Conquer over IPX. We've got multiple clusters made of multiple computers around the world, and maybe we want one pod to be able to talk to another. So how do we do these inter-cluster calls? There's a bunch of ways you could do this. You can do this, first and foremost, with the traditional layer 3 network, right, with IP. I mean, I won't bore you with the details, but it's hard, and it's annoying, and it's suboptimal, and it basically involves VPNing these 2 overlay networks together and dealing with routing and dealing with, IP clashes and dealing with IPAM and all that kind of stuff. And it's really not great, because anybody who's ever set up a VPN, anybody who's ever used a VPN, knows VPNs aren't great. But we have this service mesh, right? So in these pink boxes, we have this service mesh with this proxy being a smarter network, providing all these features and all these power. So maybe we can use that. You see where I'm going. Maybe we can use that to do inter-cluster calls. Well, we can, but you have to know how to configure it, which I'll show you today, and you have to know how to use it right as well. So maybe the sort of naive approach to doing this, these diagrams are beautiful, aren't they? The naive approach to doing this would be to say, well, we've got this big network, right? We've got this service mesh, it's a network, it's a layer 7 network, it's a super smart network, but we want this big mesh of services, so let's just make one big network, right? Let's make one big service mesh. So you see we've got one control plane, and any pod that wants to, any sidecar that wants to get configuration from its control plane ends up going up to the one sailboat that's hosted in one of these clusters. This isn't great. This isn't a great way of doing things. This has actually got all the problems of the sort of previous approach because the service mesh isn't actually a network, right? For the packets to move around, you have to have this overlay. So you need one shared layer 3 network here. So you have all the problems that you had before, and then you have additional problems as well, in that you've got one control plane, and it might be on the other side of the planet to some of the proxies that won't config. So you have real problems with performance and resiliency and scalability, security blast zones, and all that kind of stuff. So I think this works, just like VPNing the networks together would work, or just like issuing a carrier pigeon from one to the other would work. But I don't think it's the right way to do it. So we can use 2 meshes. We can have these multiple Istio, and I think this is much better. So just like their underlying clusters are isolated, their Kubernetes control planes aren't shared. They don't share anything. We have like a data plane, we have these control planes, and then there's, not shown is the sort of the management plane, right, which is you, or more realistically, your CD system, that's telling Kubernetes to deploy applications in these 2 clusters. But the clusters themselves, their control planes are completely isolated. So if we do this, then it's exactly the same for the Istio side of things as well. And for the first time, I'm showing this big purple box, which is the Istio Ingress Gateway. So all the traffic that wants to go from sort of cluster A across to cluster B can just hit that Ingress Gateway, one well-known IP, one sort of ingress point that you can whitelist or something. And we don't have to expose every pod in that second mesh to the internet, because everything can ingress through the Ingress Gateway. We can even, with a little bit more config, actually set it up so that everything comes out of the first cluster through the Egress Gateway. Again, more defense in depth, more opportunities for whitelisting and all that kind of stuff. So we can get to this kind of configuration with 2 service meshes on 2 clusters. And I think this is a pretty optimal way of doing things. I just wanted to check everybody's awake. Just wanted to check we all noticed that Istio is a word. It means sail. It has a plural, which is Istia. And I'm going to use that. Because I used it before and somebody called me on it, and I was like, no, it's in the dictionary. So there we go. So multiple Istio. If there's one takeaway before you fall asleep, many Istio. So we're not talking about inter-cluster calls anymore. We're talking about inter-mesh calls. I think it's best not to have any kind of shared layer 3 network or any kind of shared layer 7 network. So we're not just calling between the clusters. We're actually calling between the meshes. So in very broad strokes, the things we need to make this work are we need service discovery. A pod in one mesh needs to be able to discover where the pod is which other meshes a pod is in, because we want to share nothing. And we actually need a way to move the traffic around, which of course is not trivial. So quick recap, I'm sure, on Istio. I'm sure everybody knows this off by heart. These resources aren't confusing at all. A recap on the sort of networking resources of Istio. So we've got the gateway object, which basically says, please listen on this port. Basically means, please open this door to the outside world. Gateway resources, to use the right term, the YAML file, right, is not to be confused with a gateway, which is a Kubernetes deployment, like a bank of envoys actually implementing that thing. So the purple box from before is the Ingress Gateway. That's a Kubernetes deployment of several Envoy pods. The Egress Gateway is also a Kubernetes deployment of several Envoy pods. Those can be addressed as Istio Ingress Gateway and Istio Egress Gateway. Those are their names, their deployment names. And then there's another special mesh, a special gateway, sorry, called Mesh, which refers to all of the sidecar envoys. So those are the names of like gateways with a capital G, if you like, physical gateways. And then the gateway resource goes and configures those. So you target it, you're almost always at the Ingress Gateway, admittedly, and you say, I want to open this port to the outside world. Gateways have a TLS mode, right, because they're opening a port, they're listening for traffic, they need to know what to do about SSL. So they have a few TLS modes you can put them in. The first one is none. That doesn't do any TLS. The second one is simple. So this is kind of standard web serving. This would be, here's a certificate. Please present that as TLS certificate, right, so that something can establish a one-way TLS connection with me. That's usually used for actually sort of serving websites or whatever, right? So yeah, that would normally be a certificate that you've gone and domain verified or EV'd or something, and you put it in a secret, and it's like a pet certificate for your domain for sort of standard TLS. You can also put these things in mutual TLS mode, where they're expecting to do a mutual TLS exchange with something on the other end that also has certificates. And this is how pod-to-pod communications work, because remember, there's that mesh of all the sidecars, so that gateway of all the sidecars. So you can say, hey, sidecar gateway called mesh. When you open the port to talk to other pods, you're expecting to do mutual TLS with them. There's then another couple of modes. One is pass-through, which means don't terminate the TLS and pass it through. So that routes on an SNI header. If everybody's familiar with that from TLS, right? There's an unencrypted header at this, because as soon as you take an IP packet and you encrypt it, with TLS, you've then lost all the information. You can't read the header, right? You can't read the address it's trying to go to. So you wrap on another unencrypted thing, which is called the server name identification header, and it's basically another copy of the host header and says where this thing should go if you're going to pass the TLS through and not terminate it. And then there's the auto pass-through, which is magic and new, and we'll come on to it later. Service entries basically say what names exist. So when I get a packet to route, it's going to have a host header giving a name. Do I recognize that name? Do I accept that exists? And what should I do with it? Virtual services saying, okay, when I've got a name that I recognize, how do I route to the back ends? So I look at the path, I look at other headers, I look at the port number. Which set of pods do I actually send it to? And then a destination route, which is like when I've actually chosen a backend, when I've actually chosen like an IP to send it to, how do I talk to that thing? Do I inject faults? Do I retry? Do I do mutual TLS? Is the gateway on the other end in mutual TLS mode? And should I be talking to it like that? If anybody knows Nginx, then gateway is kind of the server block, right? Open the port. Virtual service is like the location block, do this path-based routing. Destination rule is like the upstreams, pick from this actual set of pods, and here's their preference order, their weighting. And then I guess service entries is kind of the DNS server you look at to turn those upstream names into IPs. So now we're all Istio experts. We will realize that it's always been possible to do this multi-cluster networking, these intermesh calls, kind of the hard way, right? So Istio 1.0 and back, you could do it, but you had to set a lot of stuff up manually. You had to really kind of grok those resources, and you had to set all of this stuff up. You needed at least 3. Istio is very powerful and very flexible, so it's always been there if you kind of knew how to cook it, but you needed at least 3 resources. So on the calling side, you needed a service entry. Okay, so one point, I'll point it out now. We're using the name foo.global when this cluster wants to call foo on the other side, right? So over here, foo has its Kubernetes ndots names, default.service.cluster.local. I got that a bit wrong. But on the left-hand side, we want to address that as foo.global. Right? We don't want it to look like a local service. I think this is an opinion. This is my opinion, and I guess the opinion of the people I work with this on, is that it shouldn't look like a local service, and you should be differentiating. If you're going to call literally around the world, you should probably be opting into that. There should probably be a good reason that, maybe I've got a database of users, all of my users, and I can have a shard in each region, so I can have a copy in each region, and they can sync data at an application layer. Right? If I'm calling the users database in another region, it's presumably because each region only holds its own users, and I'm doing some special operation. There's some special region why I want to talk to that. So the idea is that, and you're going to get a different experience calling this, right? Istio can do resiliency for you, it can do retries, but even a best case, hop is going to be hundreds of milliseconds rather than sort of hundreds of microseconds. So we think you should really want to opt into this, hence the special form of name .global. So the first thing we do is we make a service entry in this mesh saying, right, foo.global is a name that exists. We then use a gateway to punch open whatever port on the Istio Ingress Gateway on the other side, and then we attach a virtual service to that to say, right, when things hit this port number in this Ingress Gateway, I know that foo.global is actually going to go to foo in the default namespace. So it's always been possible, but it was a little bit complicated to set up like this. And this isn't really very good anyway. So you need at least these 3 per service per cluster. So that very quickly becomes a combinatorial explosion. This doesn't set up MTLS. You need a lot of extra fucking around for that. This doesn't route through the egress gateway. That can be done, but it's more resources. And you have to expose for every service that you want reachable in the cluster, you have to punch open a port on the ingress gateway. And it has to be the same. If foo is listing on 9080, you have to open 9080 here because there's no way, it's complicated, but there's really no way to sort of force everything down to 443 to go across the internet and then back to the port that it should be on internally. So it worked, and there was a proof of concept, but there was a bunch of problems with it. I guess while I got this picture up, the only other thing to explain is service discovery. So we're adding this service entry to say foo.global exists, but if there's on this side, there will be a service entry for foo.default, and that's because Istio talks to Kubernetes. It's one of its service discovery plugins, right? It says, I know I'm running in a Kubernetes cluster. Obviously, you want to be able to talk to all the Kubernetes services, so Istio will automatically make you a service entry for every Kubernetes service. There'll already be a foo.default service entry in here. Anything that Istio handles, actually, people don't realize, has to be matched against the service entry. So they're all there for all the Kubernetes ones. What we're doing is saying, I'm going to tell you about a new name because there is no foo on this side. Kubernetes doesn't know about it, so Istio doesn't know about it, and we're keeping this state completely separate. Another approach I didn't talk about for doing this was to kind of try to sync data between those 2 control planes, but again, you've just built yourself a distributed systems problem, right? And again, I really think you should be opting in to calling services across the world like this, and it shouldn't be available to all of them. So we explicitly go and make that name exist. Anyway, this was how you did it. It was just a little bit complicated. Another trip to Dictionary Corner, the word Cody Wonpil. I'm British. I assure you this exists. It's kind of Shakespearean-esque, sort of Middle English. That is an Urban Dictionary screenshot. I swear it was in the OED. I swear it was in the real dictionary when I looked it up, but I can't find it now. Maybe it's got too old. It's expired. But the word Cody Wonpil exists, and it means to go on a real stride, to really walk purposely towards somewhere that you don't really know. The reason I'm taking you to Dictionary Corner is that Cody Wonpil was the name that Zach and I at Tetrate used to make a little program called Cody Wonpil that basically, it's some really simple Go. It's got 13 GitHub stars. Anybody a maintainer here? 13. What this does is you give it a higher level description of all the services that you want to expose globally. You give it a high level description of the clusters, and it auto-generates clusters times services times 3 resources, actually times 5 to give you a few more features. So it generates reams and reams of YAML that you can pipe into your clusters. So this automated the hard way, right? And that worked in like 0.8 onwards or something. But enter Istio 1.1. This is now first class-ish. There is more support than there used to be. I'll go through it quite quickly because I'm running a little bit out of time. We love YAML. So Istio, when you install Istio, Istio is a very flexible, powerful platform. The Helm chart for it is huge, like absolutely massive. It does take, obviously, values.yaml files, and there's a few samples. If you download the Istio repo, there's a few sample values.yaml files to configure Istio for common use cases. One of which is this new sort of 1.1 based multi-cluster thing. And this is the whole values.yaml file for that. So we'll go through it bit by bit to explain what it's doing. It's basically reconfiguring some stuff at install time, and then we go and add. We only have to add one resource now in order to make multi-cluster stuff work, and it's a lot more simple. So the first thing to talk about is service discovery, and I won't really go into this because I'm running out of time. But if you think about it, when you try to make a request for, say, I want to go to my backend.global because it's in another cluster, for example, the Golang HTTP library produces something like this, right? It does a get for the path. We're HTTP 1.1, and it takes that name and it uses it as the host header. And that's great, because that's what Istio routes on, right? Istio, you put a packet on the wire, it's intercepted by the proxy. Istio doesn't care what IP address it's aiming for. Like, it just doesn't give a shit, it just throws it away. Everything's done at layer 7 based on this host header, or based on the table name if you're routing the MySQL protocol or something like that. But it's done on some application level idea of what resource you want, like AKA Fielding's thesis. The problem with this is that almost any actual library that you defer to do network calls, including the Go one, the first thing it's going to do with a URL like that is look my backend.global up in DNS, because it needs to know the IP to connect to, right? And this is pointless because, as I say, you can aim it at any IP. IP tables is just going to extract it, it's just going to intercept it straight away and look at this host header. So it'll take that name and it'll put it in the host header, but it also wants to look it up in DNS. That's not going to work because there is no such name.global. What does that mean? It's not a TDL, it's not an FQDN that you can buy, and it's just not how Istio names service. It's not how Kubernetes names services. So there is a solution to this. Every pod looks to the Kubernetes DNS server, right, to do name resolution. So if this is foo and there's a service called bar, it can look up bar, it'll get the right answer. Each cluster only, obviously, because they're isolated, each cluster only gives you the names on its own side. What we do here is we turn on Istio core DNS, which means that Istio also deploys a DNS server, a core DNS server, and that thing does resolve.global, right? It just resolves it to anything because it doesn't matter, right? It resolves it to like 127.0.0.1.69, I think, because I wrote it. But all we have to do is turn it on. So now Istio has a core DNS server. And then all we need to do is tell the Kubernetes one to defer to the Istio one to say, OK, if you see .global, it's a stub domain, go ask Istio. And Istio will say, yeah, .global, yeah, they exist, 127.0.0.1. So you get an address, and that resolution doesn't fail. Next is we turn on the Egress Gateway, the left-hand purple box, so we can route everything through it. And then we basically set an environment variable in all the pods, saying, yes, if you're going to go to the internet, then you want to go through the Egress Gateway. And that lets us do this sort of point-to-point, the best class, most defensive MTLS stuff. And it does some mangling, we'll see later. We then just turn on multi-cluster. We just set it to true. This does a few things. I'm going to have to look at the speaker notes for this. It basically has a destination rule that says any traffic aiming for a .global address should be using MTLS because Istio doesn't know what these things are. It doesn't know they're inside it doesn't know they have an Envoy next to them. So Istio wants to know whether things are inside or outside the mesh. What that actually means is, can I expect to find an Envoy next to the thing I'm talking to, and can I therefore do like MTLS negotiation? So we basically say yes. If the address is .global, consider it on the mesh, do MTLS negotiation with it. The second thing it does is it puts the Ingress Gateway into that magical new TLS mode called auto pass-through. This is a fantastic hack. And what it does is, and it tells the Egress Gateway to play this game as well. So remember before we had to have a virtual service on the other side to say, well, when this packet comes in, aiming for foo.global, you need to send it to like foo.bar in the bar namespace. What this basically does is it takes all of the information you need to do routing on the far end. It takes that virtual service and it encodes it into the SNI header. So it writes a proprietary, delimited string of, let me get this right, service name dot subset, as in Istio subset, dot port, stuffs it in the SNI header, and sends it out of the egress gateway towards the ingress gateway. Basically, this is like the internet is built, right? You are basically at each point, you know how to get to the next hop, right? The IP, the Inter-Networking Protocol, is about how to get to the next hop at layer 2. And that's exactly what this does, basically. It encodes, it knows how to get to that ingress gateway because we tell it where it is, and then it encodes the information it is on the far end in the SNI header and sends it with it. It's a fantastic hack. It works very well. And then on the ingress gateway side, it takes that host, which is obviously going to be the form foo.global, and rewrites it to foo.default.service.cluster.local. That was a fun afternoon reading the source code. The one last thing we need to do is we want to do MTLS because it's great. Think about how MTLS works. If I'm talking to another pod in this cluster, we both present certificates. We're not going to trust each other unless they're signed by the same root. The problem we have here is Istio Citadel, like each one, these aren't globally, VeriSign, RSA certificates. They're just self-signed by Istio when it starts up. That's absolutely fine. But the trust domain, therefore, is within each cluster. So that's not going to work. What we have to do is say, right, when you start up, don't self-sign a certificate. Just leave that field blank. And then we, as the user, as the management plane, have our own root cert. We sign to intermediate certs, so we provide Istio with those. So each Istio control plane has its own cert to use to sign sidecar certs, but they have the same root of trust, so that lets MTLS work. Without further ado, I'm going to try and do a demo. I tried to be smart at this demo. I tried to write we've seen too much book info. This isn't Istio 1.1, so I tried to write my own microservice that's auto-scaling and self-healing and stateless and polyglot and is, of course, global. Yeah, it's hello world. So it's written in Rust because it's the only language you ever need. Look at this. We have a trimonad. We have types. We have first-class tuples. Look at all these language features Go doesn't have. It's great. We're effectively listening on AT-AT and requesting. So this is the greeter. This is the thing that says hello. It needs to know who to say hello to. And then so it's requesting namer.default.global. Those two unwrapped there are me saying, hey, Rust, thanks for all of the safety features you've got. I'm going to throw them in the bin. The other side of it is written in Bash. Really the only two languages you need. This is a fully compliant HTTP 1.1 server, and it has minimal dependencies. So I think I've won DevOps bingo with that. Anyway, I've got a Game of Thrones joke. It's done now, isn't it? It's done. It's my Game of Thrones joke. I won't even defend it because season 8 was shit. Right. Oh, we've gone too far. Let's try to do the demo. No, I'm on the wrong screen. OK. So I've got two GKE clusters. I've brought them up already because that can be quite slow. That's really small, isn't it? Right, there's two. They're in different regions, Europe West 2 and 3. So one's, I think, just down the road and one's in Stockholm. We've got a shell into each one. Each one has a different context, I promise. Did I install Istio? No. OK, so right, we've got the clusters up. This is all scripted. The first thing to do is to install those root certificates. I'm actually really cheating and using exactly the same certificate for the root on both sides, but it's fine, that works. It's not the best security stance, but it totally works because they'll trust each other. So we install the root certificate first, and then we install Istio, which sticks in all of its CRDs, and then we have to wait for the CRDs to calcify, and then we can actually go on and uninstall the rest of Istio. I wanted to show this because I wanted to show the cert going in first, but this actually means we have to sort of drum our thumbs for a while. There we go, 53 CRDs. We can do the next thing. So we'll do that on the next cluster as well. Same root certificate. Istio. Cool. What do we do next? So the next thing we need to do is we need to get Kubernetes. So we've installed Istio with that multi-mesh values file. It's changed a few things, including getting Istio to deploy this magic core DNS server that actually just defers to a little plugin that I wrote like 6 months ago that says global, yes. We need to tell Kubernetes DNS to use it. This is Kube 1.13, but because it's GKE, it's still Kube DNS. It's not core DNS. Don't ask me why. So we have to delegate that global, .global subdomain. We have to delegate it to kubedns, which means basically writing in. This is really hard to do. A really simple config map, right, that says if it's .global, you're going to go to the IP address of Istio DNS, and we literally template that with bash. I'll do the same on the other side if it's come up. Oh, sometimes the install is non-deterministic. Just pretend everything works. I thought I had enough weights in. I thought I had enough weights in the right place. But there we go, Istio. Deploy to kubedns. Yes, good. This is really hard. Next, okay, we're going to go into hello world. Hello world world. This is cluster 1, so this is going to get my little greeter app that says hello. You saw it, it's beautiful, memory safe, Rust. Oh yeah, cheers, Matt. Cheers, pass, Matt. And we get the no. We don't have a kube config. I've got this recorded, it can't fail. I will get the recording out. But why are you trying to, where do you think that we can list? Am I being stupid? Oh, because, fuck. Don't rewrite your demo at the last minute. Fine. Okay. Let's deploy the greeter somewhere it can find the config file. Yes, yes. There we go. Right. Thanks. Small victories at this hour. I tried to get the IP of the ingress, but the ingress controller really isn't working, so we'll have to port forward to it. I applied it to this cluster 3 hours, 4 minutes ago, and it still doesn't have an IP address. So I guess they're out of GLBs in that region. Next, okay, over on the other side, cluster 2, we will deploy the name of service. The name of service is some bash that returns the word mat. And then I've got a bunch of demos in here at once. Okay, we will get. What we're doing here is getting that ingress gateway address from cluster 2. So this is cluster 1's context, but it needs to know where the next hop is. It needs to know where the ingress gateway of cluster 2 is. So we just stick that in an environment variable. And then we can make that service entry for the namer. So this is cluster 1 with the greeter. It wants to call the namer to get the word mat. So we can make that service entry. And we're going through a YAML, and we're taking cluster 2 gateway address, and we're replacing it with the real thing. So the service entry doesn't say a lot. It says, well, yeah, the thing is mesh internal, i.e. you can expect to find a proxy next to it, even though it's not in this mesh. This is the port it's listing on. It's got an address. Literally can be anything. You just need to get the packets on the wire. If you say 127, they're not going to accidentally hit anything else. So we just give it a random loopback range address. And then, so that's the address it resolves to. And the format's a little bit confusing. But then the actual place it's going to is the next hop, which is this ingress address. And then everything, this now does work in 1.1, everything is multiplexed across, everything goes across the internet on 15.443, and that can be any port you want to punch through any firewalls or whatever. And then it gets, because that magic SNI header contains the port number, it ends up in the right place on the other side. I am nearly done. This now should just work. Although I'm first going to have to find the damn thing. Cool. Oh, that was stupid. Let's come over here. because I just can't remember what the... Right, so this is what we we're really going to do, and we can curl... So this, remember, localhost 8080 is actually port forward into the pod on cluster 1. Cluster 1 with that service entry is going to call cluster 2. Hello comes from the greeter. Matt comes from the neighbor. And that is cross-cluster calls made easier with Istio 1.1. I'm out of time. I could go change the config map in cluster 2, and then it returns a different name, but the config maps take like 30 seconds to synchronize. And I don't want to keep anybody from their beer, but there you go, it works. And what we did, we did some Istio configuration, but that's all install time. There is a values file ready to go for you to do that. And, I just spent most of my time explaining how it works because this is KubeCon. You then really just need to deploy, you need to change your application to use a .global style name to opt into those calls. And then you add the one service entry that says, right, in this cluster, it is acceptable to call this service in another cluster. That's the ingress gateway IP of the other cluster. And it kind of works. And as I say, do it proper architecture, separate clusters, separate layer 3 networks, separate service meshes, keep your isolation, tell one how to talk to the other. It's very nearly first class now. That's all I've got. Thank you very much.